Hey guys, IE.RVT here, and we're looking at Module 5, Homework B, Tab 2, Part 4, and this is parallel capacitors, charge fractions. So we have already established that the total charge Q sub T in the parallel capacitor is going to be, in the parallel capacitor circuit is going to be given by Q sub T is equal to Q1 plus Q2 plus Q3. And in the previous part, we have Q1 is equal to V times C1, and then Q2 is equal to V times C2, and then Q3 is equal to V times C3. So if we go ahead and substitute these equations for total charge, we get Q sub T is equal to V times C1 plus V times C2 plus V times C3 is equal to V, and then in parentheses we have C1 plus C2 plus C3, which is equal to V times C sub T. Sorry, I ran out of space there, and my V's are looking pretty ugly, and my spacing is also looking pretty ugly. And so to find the fraction of the total charge stored in each capacitor, we can express each charge as a fraction of the total charge Q sub T. So let's go ahead and take a look at the fraction of charge in C1. So we have Q sub 1 divided by Q sub T. And that's going to be Q sub 1 divided by Q1 plus Q2 plus Q3. And now when we substitute Q1 is equal to V times C1, we get Q sub 1 divided by Q sub T is going to be V times C1 all over V times CT, which then we get C1 over CT. So that's going to be that. I don't know how to really circle that. Well, I'm just gonna do that instead. So let's go ahead and look at the fraction of charge in C2. So we have Q sub 2 divided by Q sub T, and that's going to equal to Q sub 2, and then divide by Q sub 1 plus Q sub 2 plus Q sub 3. And then from there, we're going to go ahead and substitute Q sub 2 is equal to V times C2, and that'll get us Q sub 2 divided by Q sub T is equal to V times C2 divided by V times CT, and that'll get us C sub 2 divided by C sub T. And that'll be our second answer because this is a multi-part question. So let's go ahead and look at the fraction of charge in C3. So we have Q sub 3 divided by Q sub T is equal to Q sub 3 all over Q1 plus Q2 plus Q3. And substituting Q3 is equal to V times C3, we get Q sub 3 all over Q sub T. I'm going to go ahead and fix that. Is equal to V times C sub 3 divided by V times C sub T. And then we get C sub 3 all divided by C sub T. So that's going to be our third answer right there. So those are our answers right there that should work in Snape physics. So in a parallel capacitor configuration, the total charge is distributed among the capacitors based on their capacitance values. Each capacitor's ability to store charge is proportional to its capacitance. And a thing to note about the proportional relationship, since all the capacitors experience the same voltage V, the charges are directly proportional to the capacitance values. Therefore, the larger capacitors will store a greater fraction of the total charge. And then note on the total capacitance. The total capacitance C sub T represents the overall ability of the combination to store charge. The fraction of charge stored in each capacitor relative to the total charge reflects how each individual capacitor contributes to the overall capacitance. And I hope this helped.